Lecture 1.3, Exponential Functions. This photo is Acadia National Park in Maine. The morning sunrise hits the United States first at the top of Cadillac Mountain in Acadia National Park. The park is the oldest national park east of the Mississippi River. Although some of today's lecture is from the book, some of it is not. I used to tell students that they must take notes to be successful in calculus. However, since you're watching this on a video, you do have the option of stopping and pausing whenever you need to, and taking notes later. Many students in the class will be using the TI-nspire CX-CAS calculator. Separate lectures are available with TI-89 instructions. After turning the calculator on, push the scratch pad key to get ready to work. If $100 is invested for 4 years at 5.5% interest compounded annually, the ending amount is 100 times 1.055 raised to the fourth power, or $123.88. On the TI-nspire, we type 100 times 1.055 raised to the fourth power and press enter. At the end of each year, interest is paid on the amount in the account and added back into the account, so the amount of interest gets larger each year. This is an example of an exponential function. F of x equals a to the x. In this case, x is the exponent and a is the base. Graph y equals a to the x for a equals 2, 3, 5 in a negative 5 to 5 by negative 2 to 5 window. Start by pressing the scratch pad key again to switch to the graphing mode. Press Menu. Scroll down to 3, Graph Entry Edit, and press Enter, or just press 3. Function should be highlighted. Press Enter. Input 2 to the x in the entry line. Press Enter again. And here's our first graph. To enter the next two functions, we're going to repeat some of the previous steps, but we will use a shortcut to save keystrokes. Press Menu, 3, Function should be highlighted. Press Enter. Input 3 to the x in the entry line. Instead of pressing Enter, press the down arrow once to get out of the exponent box and a second time to get a new entry line. Input 5 to the x in the entry line. Press Enter. Now we have our 3 curves graphed. Next, we will change the dimensions of the viewing window. Press Menu, scroll down to 4, Window Zoom, and press Enter, or just press 4. Window Settings is highlighted. Press Enter. Input the appropriate values on each line using the Tab key to move between lines. Note, don't use the Enter key, use the Tab key. This is a negative sign, which on the calculator is different from a minus sign. Use the symbol in the calculator that looks like a minus sign in a set of parentheses. Press Enter when finished. And there's a graph with a better viewing window. Now we can use this graph to answer some questions about these functions. Where is 2 to the x less than 3 to the x less than 5 to the x? Well, we see the 2 to the x function is drawn in blue, and looking at the graph, we see that the blue curve is lower from 0 to infinity. So our interval is x equals 0 to infinity. And notice we use a curved parentheses at the 0 because we don't count the 0. Where is 2 to the x greater than 3 to the x, greater than 5 to the x? And we see the 2 to the x curve is higher to the left of the y-axis. So our answer is x equals negative infinity to 0. Once again, an open interval. And where is 2 to the x equal 3 to the x equal 5 to the x? We can look at the graph and see where all the lines cross. Right here, where x equals 0. What is the domain? We remember that domain is the possible x values. And looking at the graph, we see that x could be anything. So the domain goes from negative infinity to positive infinity. The range is the possible y values. And looking at the graph again, we see that y approaches but doesn't touch the x-axis. And so our answer is 0 to infinity. Population growth can often be modeled with an exponential function. Here's a table of world populations from 1986 to 1991. Now we find the ratio from each year over the previous year. 523 divided by 4,936 is about 1.0176. And we do that for each pair of years. And we see that for the most part, the numbers are pretty consistent. We have one outlier, but the world population in any year is about 1.018 times the previous year. So in 2010, the population should have been, according to this model, 5,422 times 1.018 to the 19th, because it's 19 years past 1991, or about 7,609.7 million people. Now you'll have to check that on Google or something to find out how close that estimate was. But it's about 7.6 billion people in 2010. When I first started teaching calculus, this seemed way in the future. Radioactive decay can also be modeled with an exponential function. Suppose you start with 5 grams of a radioactive substance that has a half-life of 20 days. When will there be only 1 gram left? Well, we know that after 20 days, half of the substance will have changed form. So we have 5 times 1/2, or 5 halves left. After 40 days, that is 20 more days, the amount left will be cut in half again. So we have 5 times 1/2 squared, or 5/4. After t days, the amount left is 5 times 1/2 to the t over 20. In pre-calc, you solve this using logs. Today, we're going to solve it graphically, just for practice. Before we start, we need to clear the previous graph. Press Menu, 1, 4, and Enter. So we want to delete all. If you want to clear the entire scratch pad, including the axis, press Documents, B, Clear Scratch Pad. To get back to the graph screen, press the little calculator key, which is the scratch pad key. Next, we will input the new functions and new viewing window. Press Menu, press 3, press Enter. Input 1 in the entry line for f1 of x. Press the down arrow key. Input 5 times 1/2 raised to the x divided by 20 in the entry line for f2 of x. and we will use the right arrow to get out of the parentheses. So that's what we get, and press enter. Hint: if you have already entered one equation and are viewing the graph, a shortcut for entering another equation is to use the Tab key. Press Menu, Window Zoom, and Settings, and we'll choose some appropriate values. Now, we assume that we find our answer within the first 60 days, so X max is going to be 60, and we make the scale 5. That means there's a mark every 5 units on the x-axis, so it doesn't look too crowded. Y is going to go from 0 to 5. That's the 5 grams we started with. When we're all done, we press OK after using Tab to move between the lines. We can also press Enter when finished. There's our graph. We will use the calculator to find a decimal approximation for the intersection. Press Menu, 6, Analyze Graph, 4, Intersection. Notice that both graphs are flashing. If there had been more than 2 graphs, you would choose which ones you want to use. Use the touchpad to move the lower bound to the left of the intersection and press Enter. Then choose the upper bound, using the touchpad to move to the upper bound to the right of the intersection and press Enter. That tells the calculator which intersection to find in case there's more than one. The calculator has found the intersection, although it is a little difficult to read. You can hover over the number and push the plus button to increase the significant digits, then press Enter. There will be 1 gram of the substance left in approximately 46 days. We can also clean up the graph by moving the labels. While hovering over a label, push Control and Grab to grab the label, then drag it to a new position. Press Escape to put the label in the new position. And there's a cleaned up graph with labels that are readable. We can change the color of a graph. While hovering over a graph, press Control, Menu, 9, and Enter, and we get a color palette. We use the arrows to select a color, then either click the Grab key or press Enter, and press Enter again. And you see we've chosen a nice purplish color. Many real-life phenomena can be modeled by an exponential function with base e, where e is approximately equal to 2.718281828. E can be approximated by f of x equals 1 plus 1 over x to the x. As x approaches infinity, f of x approaches e. So we'll graph this equation using the techniques we've learned earlier. And we get a graph like this. We use Trace to investigate the function. Press Menu, 5, Trace, and Enter. And we can trace along the curve using the touchpad to move left and right. We can have the calculator construct a table to investigate how this function behaves as x gets much larger. Press Menu, 7, Table, Enter, and we get a table. To change the table settings, press Menu 2, Table, 5, Edit Table Settings. Tab to Table Step, change it to 1000, and press Enter. That means it'll only calculate a y value for every 1000 units of x. And now we see, by the time we go 4000 units to the right, we're getting closer to E. We can use the down arrow on the touchpad to scroll down to watch the y value approach E. To remove the table, press Menu 2, Table, 1, Remove Table.